Welcome everybody to this fourth breakout session of the EUCAD conference 2021 with the title Key Vehicle Technologies, where we are today concerned with the question, is the level of maturity sufficient for high-level automation, and meaning safe high-level automation, of course. My name is Gereon Meyer, VDE Innovation and Technique here in Berlin, where I'm involved in innovation strategy development for connected automated driving. I've been doing that for almost a decade now, particularly in the context of the European Technology Platform on Smart Systems Integration. And this is a session which is organized jointly with David Storer from Klepper, who is the leader of the Cluster 2 in-vehicle technologies in the CCAM partnership. So when we first discussed the pathways to connected automated driving in the EPOS technology platform and the ATTRACT technology platform some 6 or 7 years ago, we concluded that level 4 would be feasible in simpler operational design domains, like, for example, a motorway, very soon. We said probably already in 2025, and that this could happen by some further advancements of driver assistance systems. At the same time, we saw that automation in more complex environments, like urban environments, city traffic with pedestrians on the roads and cyclists, would probably be more difficult and would require more fundamental shifts in the concepts and environment perception and decision-making and system control. And we could hardly imagine at that time that this would happen before 2030, because it requires, as we all know, high-quality 3D representations of the environment based on sensor data fusion, sensor data usage from the vehicle and also from the infrastructure, AI-supported decision-making maybe, or even cloud-based tools like some kind of a central brain navigating vehicles through a kind of dynamic map. There were some vehicle manufacturers now making us believe that the system that they're having on the market would already provide some kind of full self-driving capabilities, and which then actually turns out as rather being a more sophisticated level 2 automation. The question, I think, is important to discuss on how mature the key technologies for safe high-level automation and automated driving really are. And that question, and the answer to that question, is of tremendous importance in the context of the CCAM partnership, because we are discussing that partnership, as you know, very much in the context of this conference, because here we need to decide on which topics to choose, which instruments to select in order to provide best funding conditions for the advancement of connected and automated driving. Before we start discussing all this with the distinguished speakers that we're having here in this panel, I actually would like to know from all the participants that are joining us today what their first gut feeling is on how mature the technologies are. I admit that the question is a bit rough at this point, but we are interested in your very first feeling and your rough gut feeling, as said. So the question is, how do you rate the current level of maturity of key technologies for level 4 automation? And we are actually launching this question in the Slido poll that you can either find in the in your viewer or on the website that is showing the conference, or through slido.com using the hashtag EUCAD. And we are giving you 6 options to answer, ordered from high to low maturity and referring to technology readiness levels, with the technology readiness level 9 being like the top, production and market development, then TRL 8, industrial product development, TRL 6 to 7, prototype and demonstration, 4 to 5, validation in lab or relevant environments, 3, proof of concept, or is it 1 to 2, basic and applied research? So I would appreciate if you could make your choice, that we can get a first feeling of how you're seeing all this. In the meanwhile, I would love to introduce our speakers, and I will start with Luisa Andreone. Luisa is with CRF Stellantis in Turin in Italy, where she is in charge of collaboration projects in automation and connectivity. She is strongly involved, for example, in the L3 pilot project, which is dealing with vehicle automation testing. She's a member of the steering committee there, and also leading the UCAR expert group on automation. Luisa, my first question to you, how would you have voted here in terms of the maturity? Which TRL is it?
Thank you, Gereon, for your question, for your kind introduction. I would have voted that it depends on the operational design domain, because you made a very important statement at the beginning when you said that the operational design domain is what counts, and now it is still limited for level 4.
Luisa, we are coming to more of that in a minute, but let me first introduce also the other speakers. The second speaker I'd like to introduce to you is Sven Biker. Sven, who has decades of experience with future mobility and automotive safety with BMW, McKinsey, and Stanford University. And I would actually ask the technicians to bring all the speakers up on the screen again. Sven has been working with BMW, McKinsey, and Stanford University, and is now the managing director of Silicon Valley Mobility and an external advisor to SAE International. And Sven and I have been working together a lot in the last few years on editing the books on road vehicle automation for the US sister conference of EUCAD, the AVS, the Automated Vehicle Symposium. Sven is joining us from Palo Alto in California, where I think it's 2 a.m. in the morning. And again, I would ask the technicians to bring up Sven and all the other speakers on the screen.
I think we are up on the screen. I think I can see one screen at least where everybody is.
There we see you, Sven. Very well.
Yes.
Sven, what would have been your vote here on this question of maturity?
Well, look, I see we've really seen great prototype testing and those field trials. So I think that makes it a TRL 6, 7, something like that. But I'm sure there's more to come and more needed. So let's discuss.
And there's probably also more you will comment on that in your presentation that we'll see in a minute. But
we'll do my best, absolutely.
Come to Samir Ariat first. Samir is a system and validation métier manager at Valeo in Bobigny in France. Samir has been working in the field of advanced driver assistance system and automated driving for more than 12 years. And also she is a member of the ISO working group 13, Safety for Automated Road Vehicles. Samir, what would have been your vote here in the poll?
Thank you, Gereon, for the introduction and for the question. So in over average, I would say I'm quite aligned with the audience voting TRL 7, because we can see in the market many experimentations already running for valid parking, for shuttles and automated driving. So yeah, TRL 7.
Okay. Very well, and as you're saying, this is very much in line indeed with the focus of the vote of the participants who were also saying it's TRL 6 and 7. The next person I'd like to introduce is Andreone of Continental. Andre is leading the autonomous driving program at Continental and has been involved in many European and national funded projects on connected and automated driving. And my question, of course, to Andre too, what would have been your choice here? Is it 6 to 7 as well?
Yeah, so I would have chosen 6, but I had also a little bit more time than my panel colleagues to prepare that, But I think it's really true. It's just an average, and it really depends on what you are specifically looking to, But I would have made it 6.
Very well, and it's gut feeling, as said. Anna Rossi, also on the panel, who is in charge of the technology partnerships at Faurecia. And Anna, who is actually an aerospace engineer, is chairing the CLEPA working group on research and innovation. And I'm interested, of course, in Anna's vote here.
Yes, not so different from the other. In fact, that's I agree with the main people what the people said about TRL 6 and 7. What I would add is really will depend on the use case and how we want to use the autonomous vehicle, because there are very large range of use cases today, and it depends what we talk about.
So a bit like the direction that Luisa was already indicating, and I'm looking forward on a discussion that we'll have on that. So when we are now going into the round of presentations, I would actually please everybody ask you to enter all your questions you may have into the Slido, and we will collect them and use them later in the question and answer session. But first of all, I would ask all of the speakers to give a short presentation on their recent experiences and also learnings in the field of connected and automated driving, their recent activities. And the first person here is Luisa Andreone. So Luisa, you are a piloting leader in the European funded project L3 pilot. And I could imagine that from that perspective of the L3 pilot, Luisa may be able to explain us a little bit the current limits of perception and prediction of road situations with automated vehicles, correct?
Thank you, Gereon. I do my best. Thank you. So,
can we see Luisa's presentation, please?
I'm not sure that.
No, we cannot see it. I believe it will come up. Can I ask the technicians to bring up the presentation of Luisa Andreone, please? There, it's coming. Thank you. All right. Luisa, can you see it too?
Not yet. Fine for me. I can do it without slides. Can we please go to the next slide? If everybody can see the slide, I'm fine. Thank you very much. So from the viewpoint of the L3 pilot project, what is the L3 pilot project? Is the biggest project funded by the European Commission on piloting for vehicle automation. And in which phase are we now? We have just ended the piloting on the functions, on the SAE level 3 functions that you see now on the screen. So talking about the parking chauffeur, level 3, level 4, talking about traffic jam chauffeur, talking about motorway chauffeur and urban. We have ended the piloting and collected the data, and all the data are now in the database in a common data format, and are now in the hands of the evaluator experts to detail the technical performances of the functions and the reaction of the users. Because we have equipped 70 vehicles and we have been running pilots in 2019 and also in 2020, despite the pandemic. What about limitations? While the parking chauffeur is a mature function that is relying on trajectory learning, and it is relying on simultaneous localization and mapping, the future is valet parking. The most challenging one is urban, because in the urban scenario, the biggest challenge is not detecting vulnerable road users, not even tracking their trajectory, but it is to predict their intention maneuvers, let alone the fact that in the urban scenario, you have lots of obstruction that are limiting the possibility for the sensors to see. To give you just one message on the traffic jam and on the motorway, one challenge is well known that there are severe weather conditions, while in the operational and design domain, it is not yet included something like construction zones and tolling station. And a challenge is also to calculate when it is dense traffic to calculate the free space for lane change. Next slide, please. Thank you. In this slide, you have the map of the 7 countries where we have been able. We wanted to do more, of course, but pandemic situation let us do really what we could. And anyhow, we did more than 400,000 kilometers in these countries. Here you also see the OEMs, the supplier, and the research institute involved in to this activity within the L3 pilot project. Maybe we can switch to the next. Next slide, please. Thank you. Mapping the challenges with a well-known document of safety first for automation. 2 main messages. For the perception, what we need a highly dynamic map of the external scenario with respect to the vehicle automation. We need precise positioning because we are not yet there to have a positioning of 10 centimeters. And we need to address severe weather conditions. Unless we accept that for the future market, severe weather conditions are not within the operational design domain. For prediction, what is difficult is to predict the intention. It is easy for us human, it is not easy for vehicle automation. Next slide, please. Here is, of course, only a graphical representation. To try to give a first answer, and we will start with the High Drive European project to give a first answer on how connectivity can support vehicle automation. We are representing it schematically, not in scale, of course, in 3 ways. Being redundant sensor to the other sensors like camera, radar, and LiDAR, extend the sensor visibility beyond sensor range, and have a kind of a digital cocoon that is anticipatory information about a dynamic change of the ODD. Like, for example, in 1 kilometer, you have a bank of fog. Next slide, please. My last message is just to a question on the table. Again, we will start with the High Drive project. We need to leverage on most recent machine learning techniques. And a very urgent need recognized by the expert is to create a large data set of automatically annotated video scenarios to be able to substantially train the supervised machine learning techniques of the future, let alone the fact that machine learning can help a lot also in prediction. But this is an even bigger challenge. So thank you for your time, and I get back to Gereon. Thank you.
Luisa, thank you very much. Thank you for making us aware of the role of considering the operational design domain and what it all implies, like urban driving, for example, weather conditions and so on. These directly, I believe, have impact on what technologies are needed. And there again, we already start to differentiate a little bit the question of maturity. And then you, I believe, rightly made us aware of the fact that we need to consider also the opportunities of using more intelligence in the vehicle, artificial intelligence, deep learning, machine learning, as you're saying. And this brings me now to Sven Biker, who is actually representing SAE International in the Silicon Valley. And if there is anybody who should be able to tell us what the challenges in terms of technologies, particularly for sensing and perception, are in order to reach and achieve highly automated driving according to SAE level 4, I believe it's Sven. And the question that specifically I do have to Sven is, when we hear Elon Musk saying that LiDAR is a fool's errand, is he right?
Well, let's see. I don't claim to be smarter than Elon Musk, but I certainly have my own perspective about this. And well, look, I mean, you're asking me this question just days after a very tragic event happened with one of Tesla's products. And I do think it's an amazing technology that's out there on the roads, but it can definitely be further improved. And adding a LiDAR to an automobile, I think can make it even safer. But certainly the technology does not get less complex, and I think that's what we should discuss a little bit more. So I'm happy to go through my slide deck if that can be queued up.
Can we get Sven's presentation, please?
And while this is coming up, so as Gereon pointed out, so that's some work that I've been doing at SAE International, which basically goes back to the question, well, these sensors, we always talk about them, but what are really their strengths and how might they be complementary? So if we can go to the next slide, please. So as Luisa already pointed out, what needs to happen in order to navigate the roads out there. I picked a few examples here on the more challenging situations maybe that can happen, and the audience, please, you can read those 10 situations by yourself. But if you only just pick any single one of them, we basically see it's not as straightforward as there's a perception sensor, maybe a camera, maybe a LiDAR, that picks up an object, and then the whole magic in the artificial intelligence starts and ultimately applies brakes, steering, or powertrain. Just if you take the one at the top left corner here, object obstruction. So there's 3 primary objects in this little image there, which is a tree, a person, and an umbrella. And to just separate those can be very challenging because they have different meanings, obviously. And if you just think about an umbrella, even if you don't see a person as a driver, and I think that's also what Luisa pointed out, like the context and almost intuition. If you see an umbrella, then there's probably a person as well. And as humans, we actually know this, but how do you teach this? An automated system? Or the third from the top on the left side, that a soda can, so we're looking at a Pepsi Cola can, obviously, has the same radar reflection as a human person. But obviously what the automation system should do can be very, very different. And on the right, if you just take the second from the top, which is a plastic bag, relatively large object, but probably no action necessary. And the one just below, it's even slightly smaller, tire debris. It's about the smallest object that a system actually should pick up and take an action. So that's kind of the spectrum that we need to look up. And so therefore, how do we do this? And if we can go to the next slide. So we obviously have camera, radar, and LiDAR sensors, and there's a lot of text on these slides here. But basically what they are supposed to tell you is they all have different strengths and weaknesses. If we just think about a camera on the very left here, the nice thing is the camera works because there's light that shines on an object. Here we take the sunlight, and the light gets reflected and gets into an imager. The nice thing is there's a lot of light out there, and therefore we can see relatively well, and the camera can see relatively well. But the bad news is there's a lot of light out there, and we get a lot of information, and therefore a camera might get overwhelmed with the information, which is why it is not perfect. Radar in the middle sends out a fan, and whatever's in that fan of a radar signal basically gets tracked, which is, it's not as precise as LiDAR, for instance, on the very right of that image, which sends out a lot of beams, and whatever that beam hits, it's very precise actually and gets you the information of what might be out there. But if you look at the green and red icons down there, the pluses and the minuses, a camera is very good for color, but actually not so great in bad weather. A radar actually is very good at object distance, bad weather as well, but actually it doesn't get you color and that cannot track the lanes of the vehicle. And the LiDAR is, again, very, very precise about an object and angular resolution, but not so good at lane tracking. So if we go to the next slide, please. What is obvious what needs to be done, you need to combine those. So here you have a more detailed listing of the pluses and minuses. In green, obviously the pluses, in red, the minuses. And you basically see on the right column in Fusion, if we were able to combine all of these aspects, then it would be a pretty perfect world. But if you go to the 2 rows on the bottom there, cost is a little bit unclear if you want to take everything. And the production readiness is also unclear. Basically, with LiDAR, we are now in a situation where the first are being launched into market. Actually, the very first was in 2017, I believe it was, that Audi launched the A8. And since then, there are a few LiDAR solutions here and there. And that's maybe in answering your question, Gereon. One can say maybe it's not really ready. Some say it might not be needed, but so we need to figure out more what actually the overall package is supposed to be and what we put into Fusion. So if we go to the next slide, Fusion is actually talked about a lot, but we should keep in mind there's not just one Fusion thing. And here are 3 examples. On the left, you look at low-level Fusion, which basically is there you get from maybe 3 different sensors, you get the raw data and you pull this together, which you can imagine like you get some camera data, you get some LiDAR data, and then you pull it together. Excuse me. But how do you make sure that they actually are looking at the same thing if they are looking at the same angle? Because the angle might be a little bit off, and one might be looking at a tree and the other one at a person, and they think it's the same object, but maybe not really. So Fusion is not that straightforward, which is why you can do on the very right. You track the individual objects with your individual system, and then actually you pull it together into your Fusion, which actually requires also a lot of mathematics and computation to classify all these objects. So therefore, there's some middle ground approach that quite a few experts are proposing here, which is to extract features out of the different objects that the sensors are looking at, and you pull these features together, and then you track those in common. There's obviously much more technology behind this that we can discuss for the rest of the day. But just keep in mind, there's a lot of work still on sensors and how to fuse all this information together that has also not been ultimately determined, and certainly more work to come, which we might discuss a little bit later in the session as well. But let's go to the next slide, which talks a little bit more about the market situation here. So on this slide, on the horizontal axis, you actually see the prospective market size for camera in yellow, for radar in blue, and for LiDAR in gray. And on the vertical, you see the CAGR, the compound annual growth rate. So basically the expectation, what's the percentage that this market is going to grow? And you obviously see that LiDAR is expected to be the highest growth. Camera relatively saturated, not that much of a growth, but still 10 to 20% growth. I take that. But there are so many cameras expected in the vehicle, which is why the market for cameras is going to be the largest. And that's also what you see in the first bullet point there on the right. If you assume a camera is relatively inexpensive, $40 is a little bit on the higher end already. LiDAR is relatively expensive, about $200 plus when it comes to the market. But there you see basically there will be a lot of cameras in the vehicle, and therefore pretty big market size in that. If we go to the next slide, which is what I want to be closing with here, and that's something that my SAE colleagues actually came up with when I said, hey, what else should we discuss? And they said, let's don't just talk about the great characteristics and performance of these systems when they come into the vehicle. Let's also talk about what happens if they are in the vehicle for 10 years, if not more, and there might be smaller accidents, and some of these sensors need to get replaced. They actually need to recalibrate those. And these are those 3 groups of columns here. On the very left, you basically have how does a system react when there's an object and there's an automated emergency braking. Basically, you can see that the system gives a driver warning after 3.38 seconds, and after 1.48 seconds before impact, it starts to brake, and 0 miles per hour at the top, it avoids the collision. If you just replace the sensor and don't calibrate it, actually you end up with a crash, which means on the right side of this column, you need to recalibrate the system, so avoid a crash. So, which tells us these systems are getting more and more complicated, and we also need to figure out how do they actually get dealt with in the workshop and the repair shop, and what extra equipment is needed in order to make sure that these systems always work. And that's where SAE International has launched a lot of activities as well to not just figure out what is the best sensor, but how do we maintain system integrity in the field once the vehicles age and need to get maintenance and repaired. Happy to discuss more, but I guess we hand on the baton to the next speaker. Thanks for the audience.
Sven, thank you very much. We may want to look into the question of whether there may be a radar camera at some point competing with LiDAR. But before we do that, I'd rather want to introduce or ask the next speaker to present, and that's Samia Ayad, who is, as I already said, a systems evaluation team manager with Valeo. And Samia, as you are probably the person with the most experience in safety assessments for connected and automated driving here in our panel, my question, of course, is how you define safety requirements for the sensing that is required for level 4 automation, and how that relates, how the requirements to the system and the understanding of the safety of the system. Yeah, and I believe you have some slides on that, right?
Yes, thank you, Gereon, for the question again. So through my presentation, I will try to share some of our experience about how we deal with sensing limitations when designing automated driving level 4 systems. If we go to the next slide, please. I will start by sharing just an overview of Valeo products regarding ADAS and AD. So Valeo providing sensors and ECUs, in addition to the software, of course, that might be computer vision, signal processing, up to the end user function. So we are not only providing components like sensors, but also systems. And this is a key asset when we develop our sensors, because we can consider in early stages the end user requirements and the vehicle safety requirements as well. Now, if we move to the next slide, please. Thank you. And if we look to each single technology of sensing alone, of course, we see advantages and limitations. I'm not going to enter into details. It was well explained by Sven just before. So just to give you some examples, we know, for example, that for ultrasonic, they are very good in short distance measurement, but they can be impacted by the reflectivity of obstacles. In parallel, the LiDAR, for example, is very good in the high distances or the high range accuracy measurement, but might be as well disturbed by projection of water drops on road. And the knowledge of these limitations and capabilities of each sensor technology is very important when designing ADS architectures. And if we move to the next slide on the ADS architecture, so of course we need both approaches, a top-down and a bottom-up approach. Top-down meaning we need to start with end-user expectations, whether they're about comfort, availability, or safety, to derive them up to the sensing components level using engineering processes to define the KPIs that should be handled by the sensors in one hand. In the other hand, we also need to consider in the bottom-up approach the return of experience or the retext that we have from our sensors that are embedded in different cars running in the real world, with the experience we can get from that about their capabilities. So both approaches are needed. And at the end of the day, the ADS architecture needs to fulfill many safety-related requirements. So we are talking about the integrity level. Here, the main ECU shall be ASIL-D. The backup ECU shall be at least ASIL-B. Regarding the diversity, safety specialists, I think, are all agree about the necessity of having diversity in terms of sensing, of course, and in Valeo, we believe we need at least 3 diverse technologies to be able to build a fail or a fault-tolerant architecture in analogy to the Byzantine general's problem in the military domain. Availability. So here it means that if the main ECU or if the sensing encounters a failure or fault leading to a failure and a risk of a hazard, then we cannot just switch off the system. We need to continue the operation, relying on a backup ECU, for example, or requesting a teleoperation assistance. And regarding the robustness, of course, we can implement many strategies to ensure robustness of sensing, like, for example, cleaning devices in order to restore the visibility of the sensing and recover the capability of the full system, or some fusion strategies, as explained just before, or some specific strategies for safety check and availability extension. And last but not least, the monitoring of the health of the ADS system completely and sensing in particular is also very important in order to be able to solve each single fault and to mitigate it, and if not, at least to have a last resort strategy by fallback and minimum risk maneuver strategies. If we can go to the next slide, please. Just going to give an example of a sensing limitation. So here in the left picture, we have the left rear sensor, which is not anymore available, let's say due to a hardware failure or to a blockage because of dirt, for example. Then the ADS has two options. First one is to clean the sensor if a cleaning device is available, if it is in the car, or otherwise to degrade the capability of the system to a manageable level, like, for example, changing the lane to the right twice, as you can see in the middle picture, until reaching a safe area to stop the car. So this is as a last resort strategy, and then maybe to request teleoperation or a remote operation assistance. And in the last slide, next slide, please. Just to summarize, a few points here. First, I insist on the importance of an engineering framework in order to derive sensing KPIs and sensing requirements from end user expectations, including safety, availability, and comfort. After that, the sensing should be diversified. This is a mandatory requirement for safety. Availability can be extended and enhanced due to high performance sensors, but also to some software and fusion strategies. And at the end, as a last resort, we should have a robust strategies for fallback and MRM in order to increase the availability, the safety, and also the user acceptance of such systems. So thank you for your attention. I would be happy to answer your questions.
Yeah, thank you, Samia. I do have a quick question that I'm just seeing in the chat right now, and people are wondering whether sensors could also be an entry point for manipulation and for hacking. How do you see that?
Of course, exactly. There is a risk to be hacked or to have some cyber attacks in sensors as entry points. This is why we have also specialists in cybersecurity domain that considers in early stages of the designs these risks in order to implement some mitigation measures. And at the end of the day, of course, we shall always provide argumentations and prove that our sensors are robust regarding this kind of risks as well.
Thank you. So this brings us to Andreone. Andreone, as you are in charge of the autonomous driving program with a major tier 1 supplier, can you tell us whether all the required technologies for level 3 automation are in place? Do you have them all on the market, or is there any challenges that you still see?
Yeah, so there are still a lot of challenges. Of course, we have all the categories on the market, yeah, but we have to make them still ready for higher levels of automation, yeah, which I can point a little bit more out in the presentation, yeah. So yeah, good morning again here from Frankfurt. Very happy to be a part of that, and I'm also happy to see all the stakeholders here which are interested in the future of mobility. I want especially to focus on the topic of driverless mobility, yeah, because that's higher autonomy levels in the most extreme form, and it could be also considered like a kind of holy grail of autonomous driving, yeah. I will also introduce some aspects where we think they are really important. They are on the critical path. These are really critical factors which we all, as the industry and society, should tackle to overcome, because they are really the remaining hurdles in that journey. So next chart, please. So first of all, driverless mobility is coming in numerous forms. I'm sure that you already saw a lot of images like that. I mean, every big company has such a thing, yeah, where you see a glimpse of how the mobility of the future looks like. We see that there is a combination of many different vehicles, and all these views have one thing in common. They see a quite important role in really driverless vehicles. Yeah, so you see, for example, one of these driverless shuttles moving people around, yeah, which are shared vehicles. But also imagine traditional cars, which, for example, while searching a parking space in a parking garage, could also be operated in a totally driverless way. Yeah, so it's not really dependent on the vehicle platform. But driverless operation will be really something very important. So it's well worth taking a look in that. Next chart, please. Yeah, so if we take a look about why we are not still there, because if you take a look out of the window, you won't see any real driverless vehicles in daily operation. And the question is now, what are the reasons for that? Yeah? And we see three big groups for these reasons. First is technology. Then we have the topic of homologation, and of course, it's always important to get acceptance for that. Yeah. Next chart, where I want to start with a deeper look into the technology item, which is also the focal point for this discussion today. Next chart, please. So first of all, I think it's very important to understand that driverless mobility is really, it's not one single product. Yeah, so it's first of all a combination out of many technological puzzle pieces, which only in their combination, in their architecture, achieve the intended ability to be autonomous, to be driverless. Yeah. And there's a large number of technological puzzle pieces, products. We heard a lot of them right now, a camera, radar, LiDAR, for example, and all of them have to be combined in a suitable way. But besides those physical products, there's also one very important thing, and this is the competency to combine them into a kind of interconnected functionality. Next chart, please. So if we focus now on one of these puzzle pieces, which is here the reliable detection and perception of what is going currently on around the vehicle, then we are really at the, in our view, most critical factor here. Yeah? But also we have to say, teaching cars how to perceive their environments, that's not a new thing. Yeah, Gereon, you said that in the introduction. For years, almost decades, we can say the industry is working on driver assistance systems, which we really can use as a very solid foundation for developing out of them higher levels of automation. Next chart. So to make the car see, we have different opportunities. I don't want to go deeper into camera, radar, LiDAR. We heard them a lot, and obviously this is what physics provide us in opportunities, how we can make the vehicle see. We see a big additional opportunity on the right upper side if we are integrating the infrastructure, the environmental infrastructure into that perception system. Yeah, so for example, making an intersection see, yeah, and then cable that information back to the car, which is also extending a lot the senses of the vehicle. One important factor, though, is if we are combining all these different sources of information, we also have to be able to digest all this information, which is leading to the necessity of powerful ECUs, of powerful computers that are able to digest all that. Yeah, so the computing capability is also a very important technological building block here. Next chart, please. Yeah, so combining all these technologies now into a, let's say, perception system for driverless vehicles. The target is obviously that you give the vehicle the ability to cover 100% of all the situations a vehicle could be in. Yeah, so 100% coverage. Coming back to your initial question, Gereon, are we still there? I would say no, we are not still there, because I mean it's hardly reasonable to assume that just with one development step, with 2 or 3 years working on driverless mobility, yeah, we can just make that happen, that 100% coverage. Yeah, it's just a range of different situations is far too broad that you could expect that. Yeah, so you see here some examples of these edge cases. They are not happening often, but I'm sure you can, out of your driving experience, tell that from time to time they are happening. And so the vehicle has to have at least a plan if you have scenarios like that. Next chart, please. So given all that, it is hardly surprising that I come to the conclusion we are not there yet when it comes to driverless functionalities. And the big question is, where do we stand? And just to get an order of magnitude, yeah. So on the left side, you see a number of collisions normalized to 1 million miles from an accident report from the US. And if we now include all accidents here, yeah, also including accidents where there is also only sheet metal damage, then we can conclude that we have to reckon with around 2 of these collisions. So this is manually driven, 2 collisions per 1 million miles. So on the right-hand side, we see, in contrast to that, also standardized to 1 million miles, the number of interventions which a human safety driver had to do while doing one of these nice autonomous driving pilot deployments in California. Yeah? And if we are roughly assume that almost all of these interventions can be traced back to some kind of glitch in the environment perception, and we assume that the safety driver had to intervene to avoid a collision, then these 2 numbers become at least a little bit comparable. Yeah? And if we compare them, then we see the direction time-wise is very good. So we're making big progress, but we are not really in a comparable level of safety here. Yeah? Next chart, please. So just very super short on homologation. Next chart, please. I think there are a lot of initiatives worldwide, and also, so next chart, please. And we also saw many steps forward. Yeah, just one example, in the UNECE from this January, we have the opportunity to get a homologation for a so-called traffic jam level 3 system, where it's able really to get a okay to put such a system on the market. It's not really driverless, but it's taking to a large extent the human driver out of the equation. And this is a good sign that things are moving forward. Of course, we have to move forward all around the world, and a lot of steps are still open, but we see a lot of good and pragmatic movement here. Next chart. And last but not least, the acceptance. I mean, all that is in vain if end users are not ready to use all that. We go to the next chart. Then we see that even today, we have a big spectrum of very well accepted means of mobility, for which we see that on the next chart. We see also quite precise numbers concerning their safety. Please, could you go to the next chart, please? This is giving us a good, let's say, target corridor about what our technology has to be able to achieve before we even have a chance that it is accepted by the society. Yeah, so that's the target we should approach in terms of acceptance. And if you now go to the next chart, this is my closing one. Just to give you a summary in terms of technologies, we are on the right way. There are a lot of still open questions which we have to answer. The most pressing one is, in my view, the topic of a safe perception system, which then can also be homologated. and also leading to, let's say, overall vehicle systems, driverless or highly automated, which at the end are receiving the acceptance by the end user. So this were my charts. Thank you very much.
Very well. Thank you, Andre, for providing such a comprehensive picture and overview of all the challenges. And referring to the title of your presentation, are we yet there? Or, well, you could, of course, as you did, respond and say where still the challenges are, but maybe the little bit unfair thing that I, as a moderator, may ask is, so when will we be there? So what's your estimate? How long will it still take?
Yeah, so I mean, it's with every complex question, the answer is always, it depends. Yeah. So if we take a look about very specialized application areas of driverless, yeah, so talk about private grounds like big theme parks, big industrial parks, airports, or also fairgrounds, for example, yeah, where you would have a lot of need for mobility. I think we will see commercial applications of that very, very soon, yeah, because velocity is a little bit lower and so on. So this is the next step where we'll see that on the market. If we are really talking about the fully fledged driverless solutions with robo-taxis, 60, 70 kph, mixed traffic with human drivers all around our big cities, I think that's definitely taking still until the end of the decade.
We'll learn about the assessments of the other panelists in a minute, but before doing that, let us turn to Anna Rossi. And Anna, let's assume that sensing and decision-making is all working safely. And from what we heard, we are on a very good path to that. Still, Andrea already mentioned the dimension of acceptance and of human factors. There are people on the road, and even more, there are even people in the vehicle. And this may directly have and lead to further technical challenges too. And maybe you could explain us a little bit what still needs to be done in that field.
Yes, and thanks, Gereon, for the introduction. The short answer is that no, we are not done yet. There is things that needs to be done. And with that, in fact, I'd like to present today how life on board will shape requirements for higher level automation, because life on board, in fact, it's an important ingredient to this recipe. So if we go to next slide. So as we move to higher level of automation modes, we know that the driver is going to be less and less of a driver, is going to be more and more of a passenger. At the same time, we see that the range of possible activities in the vehicle will increase. But the problem is that it would be too simple just to consider such an autonomous vehicle just like a lounge or an office with wheels. In fact, the reality is a little bit more complex, and we can expect a strong impact on the design of interiors. So if we go to next slide. Well, first of all, we need to consider, of course, safety. Because with autonomous vehicle, we will see a very much higher variety of activities, as I said before, that can be done in the vehicles. So this also brings to a high variety of configuration. For example, for the seats, you will have people that may be rest, you will have people that may just be working. This will be complemented with an increase in furniture inside the vehicle, so more screen, for example. We may envision to have a table inside. So in this framework, it's really, really important to have a clear view of what is going on inside the vehicle. For example, what is the posture or the seat adjustment of the passenger, what is doing at a certain point, so that if there is an accident, the vehicle can adapt the response. And we do have the right response to the accident. If we go to the next slide. So still on the part of the safety, until we reach high automation modes and complete autonomy, we will have these mixed modes where the driver or the passenger, as you call it, will have to regain control. So it is really important to make sure that the driver can regain control at a certain point. So we will have to monitor things about like distraction or fatigue. But also it is important at the same time to be able that the vehicle is able to provide some energizing feature. It could be, I don't know, a smell to wake up his senses, or it could be any HMI related to sound or vibrations, so that the driver really has the right level of concentration when he retakes the control of the vehicle. Another aspect that we really need to take into account is that these people that will drive less and less because we go through more autonomous vehicles. So we may expect that there is going to be a loss of driving expertise. Maybe in some population more than the other, we can expect that the aging population will behave differently from the young one. So it is really important to see how we handle this stressful situation. You can go back to the previous slide. Yeah, how we handle stressful situations and how we manage high cognitive load when the driver needs to retake control. So if we go to the next slide, in fact, we see that one of the use case of autonomous vehicle is ride-sharing services, for example. And this type of services today are well accepted and widespread. But what happened is also that today there is a driver that makes sure that everything goes well. And is really the responsible element to make sure that people behave correctly and everybody feels well. But what happens if the driver is not there anymore? And you will see that in this case, you will have occupants that will be sharing a limited space together, people that don't know each other. And if I can do an analogy, it's just like being in an elevator with people that you don't know, except that the drive is going to be, the trip is going to be much longer. So there are a new set of challenges and elements that you really need to take into account, like, for example, coexistence and social interaction, how good people behave with respect to each other, and also safety problems. And I would say another element just to make sure that we have a good accessibility, also individual comfort of the people. Not to be forgot is accessibility and inclusivity, the fact that because again we want these services to be as accessible and inclusive as possible, so we really need to take account any specific need that facilitate inclusiveness when the driver is not there anymore, to make sure that everything goes well. Next slide. So this it's a given, and we know it, but it's good to reassess it, is that as drivers will be spending less time driving, we can see an increase of expectation in infotainment that can be for safety, for productivity, for entertainment, and this needs to be also in continuity with the personal environment from home. If I go to the next slide, so I like to conclude that yes, human inside the vehicle is very important. We really need to take into account life on board, and to associate it to the human, there are some non-trivial challenges from technology point of view that we need to solve to have an attractive and safe autonomous vehicle.
Yeah.
This I complete the presentation.
Yeah, thank you very much, Anna. Very well, and so I very much appreciated that you're making us aware of the challenges of life on board of automated vehicles and the implication that still has on technology development. And I think that's completing, in a sense, a bit the picture that we have seen before. So with Luisa, Andreone from CRF Stellantis telling us about the challenges of environment perception in complex operational design domains like city driving or bad weather conditions, or with Sven Biker assessing the opportunities and challenges of the different sensor systems, camera, radar, and LiDAR for us, or Samia Ayat telling us about the safety limitations of the perception systems, and Andreone then giving us a comprehensive picture of all the enabling technologies, where we stand and where we definitely are not yet finished with the development work and probably also the research work. And then finally, thank you, Anna, for completing that with a view on the challenges inside the vehicle for the people that are driving or being passengers in that. Before we go a little bit deeper into a discussion, I would actually ask all participants to respond to one more question. I mean, we have seen before that most of you believe we are probably in the area of TRL level 6 and 7 with many of the technologies that we need for automated driving. At the same time, the speakers have made us aware of challenges here and there that sound a bit more like some fundamental questions still need to be answered and need to be researched. And therefore, our second part question is, which key technologies of SAE level 4 automation will require significant further research and development, say up to TRL level 5 or 6, right, over the coming years? Because as said, in the CCAM partnership, we need to develop recommendations for further research topics in the coming years, and therefore it is of course of great interest to know what needs to be further explored and where there is further research needs. So if you could do that, and we'll just let that running in parallel to the panel discussion. We may refer to that at some point later in this session. So maybe if we now come to the panel discussion, I would actually ask the speakers to consider a little bit more the dimension of intelligence. So we have talked a lot about environment perception, about the opportunities, the sensors and systems that where they are in terms of their maturity. And the one or the other already mentioned that, of course, we need to consider how to understand all these data and how to use them. I believe, Luisa, you mentioned in the end of the day, it's a question of understanding the intentions of people on the road. And I also could imagine that Samia may have some ideas on that, knowing that you're also deeply in the artificial intelligence part and how this contributes to the safety of the systems. So maybe if I may ask Luisa to first comment on that question of how to use the opportunities of artificial intelligence, and whether that could help us to make the system in the end of the day as reliable or maybe even more safe than what a system driven by a human person would be. Because that's also a question that people are asking in the chat. Luisa, could you comment on that?
Thank you, Gereon. I want to give a very simple answer, if I may, because it's a matter of learning, and learning from the, let me say, as extensive and as reliable set of data. Otherwise, we will never be possible to address a situation like a speaker before said, for example, an umbrella is hiding a vulnerable road user, and then intuitively a human understands that this is a human, but how can? There are millions of these situations. So if you are able to have a data set that are available for training the first generation of machine learning that is supervised, this would be a great step forward. And then I would not underestimate the fact that in parallel, we have a development with unsupervised, with reinforcement learning. So all this, in my understanding, should possibly go in parallel.
Yeah, Luisa, so a big call for considering that intelligent systems, of course, require knowledge and need to gather knowledge before, right? Samia, so what's your understanding or your perspective on using artificial intelligence to make automated driving more safe?
Yeah, so I agree on the fact that data is a key, real key challenge to gather more data, annotate it, train and in the right way and get the right performances from the AI and machine learning algorithms. But one thing that is important to say is that machine learning exists already since many years in sensors that are embedded in vehicles, on millions of cars that are already running on road for assistance in particular. And in the future, I expect, from what I see today, that there will be at least 3 dimensions for the evolution of the machine learning. The first one is they will be more and more capable in terms of performance, in terms of capacity to detect, predict the intentions and the behaviors of the surrounding actors and agents around the car. The second axis is the evolution in their capability of auto or self-assessment of their performances to have more explainability and more, I would say, confidence on what they can give as an output. And the third dimension of the evolution is the capability to be proven or to be used in a safe manner in an architecture. Because today we, of course, we all have in mind, I guess, the fact that when we put a machine learning algorithm or a probabilistic algorithm, we need to have a deterministic parallel path to monitor the first one and to check that the outputs are safe. But yeah, there will be also an evolution in that sense in terms of design and architecture, considering the capabilities and limitations of such algorithms.
I guess this will have some implications for testing as well, right? So
exactly.
Yeah. Mm. So how would you? So what's your understanding of testing such a system? Is it like, as you're saying, it's it may not be predictable in some cases. It may not be deterministic. So it's like a system you do not fully know, right? And that's kind of testing like a human that's learning something, right? Is it a bit like that?
It's not only testing on all situations the performance of the AI and the machine learning, but it's also about testing the capability of the machine learning to say at a certain time, I'm not able to give you the answer. This is also one of the key elements in the testing to understand the limits and the boundaries of the AI and machine learning.
Maybe let's try to come back a little bit to the technology dimension, maybe a little bit more to the hardware side what we're talking about here in this session, and the question where this intelligence is coming in. Maybe a question to Sven, if we're considering like a LiDAR system and we are asking what knowledge will be needed for a more intelligent algorithm to run on that, wouldn't that require quite complex data sets representing like in a 3D manner the whole environment of the vehicle? These are big data sets. Do you see a chance to collect all those and simulate? Is that a challenge?
Well, let's see. I mean, there are definitely many approaches that are trying just that. And speaking here from Silicon Valley, where very often you get an answer that with data everything is possible, and that many players, especially the well-known household names in that game, talk a lot about the data-driven approach. And very often then you get the impression those who have the data automatically are assumed to be the ones who will figure all of that out. However, I will also say that there's a somewhat evolving school of thought. It's like asking the question, are we not making this way too complicated? And do we maybe need to break this down to a less data intense approach, which is a challenge, of course. But it's not automatically something if you say the more data, the better. So you obviously need to have the right data. And this is where certainly labeling and annotation and all of this comes in. But I think the overall challenge in this is that we are trying to mix machines with humans on the road. And that means that we are trying to adapt the machines to the human behavior. And if at all, I personally think we definitely should adapt the machines to the humans as opposed to adapting the humans to the machines. But I think in the end, it probably becomes a question, what does the traffic setting of the future look like? And is it really something where we can mix all of this together? So my personal take on this is, yes, data is very important, and we need to figure out how to run all this data, what the architecture is that actually can process all this data. But at some point, we need to be, I guess, realistic and say we have to keep complexity at a certain level and use a fundamental set of data as opposed to trying to describe each and everything with data points. I think
yeah,
it's impossible.
Sven, I like this, and also it gives us the opportunity of going back a little bit to the capabilities of technology and also hardware. And considering that a human, usually you and I and all of us, in a certain sense, we're able to estimate how far something is away, and we can also probably understand what it is and what it means, right? And of course, getting closer to that is the challenge of environment perception, with LiDAR systems being probably quite close to that, being able to deliver the 3D images that say that can give you an idea how far things are away and probably what it is. Whether what cameras can probably do just one part of that, they cannot estimate how far things are away, and radars are just the opposite of it. How do you see these trends of combining radar and camera capabilities into one device, and in comparison to LiDAR? Is it an option for a path in the future, or do you think the LiDAR system is superior anyway?
Well, in a way, you're getting back to the Elon Musk statement about the fool's errand, and I definitely appreciate this. Look, it depends. What is the ODD? What is the use case? What is the vehicle we are trying to deploy? If our, let's say, gold standard is there's an automobile with a human driver in a just everyday traffic scenario, whether that's a highway or a complex city environment or anything in between. I personally think you better start with all three kinds of sensors. That means radar, camera, and LiDAR. And at some point, we might arrive at something where we say 2 is just good enough. And I think there's reason to believe that you can accomplish a lot of things with camera and radar. And I'm actually very glad to see that some suppliers, and I think some of those are on the panel here, are launching integrated solutions because that somewhat gets us back to the architecture question. I mean, can you just mix and match all of these sensors, or where do you actually go for an integrated system and then make it part of the bigger complex approach? And
Sven, let's make this
integration of those is very promising. Sorry.
Let's make this a question to Andrea right away. I mean,
I was thinking,
probably we're seeing Continental having all these different technologies available in terms of perception and decision making. How far are we in combining all of those in a as modules and integrate them into a new architecture? Does this require like a step change in our understanding of the electronic architecture? Or is it just easily putting an additional device here and there and running just a new control system on that? Maybe Andre Homo, if you could assess that would be very interesting.
Yeah. So I think first we have to differentiate here. The first thing is that we have to be careful to do things in right order, because we have a lot of times these discussions about, hey, cannot can't we get rid of the LiDAR sensor? Could it not just work also with a camera and radar alone, or just with one type of sensor? Yeah. And to be honest, I don't like this discussion very much, because it's not in the right order. Yeah. So we have to understand that at least higher autonomy levels, or even driverless driving, that's a technically unresolved thing. Yeah. So where everyone is still working on. Yeah. So first step is very clearly make it happen with everything you have in the toolbox. And if then it's working fine, you can start these discussions about, hey, can we make it simpler? Can we make it cheaper? Can we combine things? Can we leave whole sensor categories away? Yeah, so that's the right direction. Therefore, I would not start tackling the general question, is higher autonomy technically feasible, with the aspect of reducing several sensors. Yeah, so this is my, let's say, general message. Yeah, so this leads me to the impression that it could be very reasonable to use camera, radar, and LiDAR and try to make it happen. And of course, people are always then afraid to say, hey, that's super complex. Yeah? Then we have 30 sensors and everything has to be fused together to have that overall image. Is that even possible? Yeah? And maybe we can make it easier while still using all these different types of sensors, because they do not have all contribute to one chain of effects of perception digestion. Yeah, but we could also think of maybe, let's say, one is the high performance path, which is taking all these challenging scenarios with CNNs and whatever. Yeah, and if there is a kind of, let's say, in parallel, you have a kind of safety path, much simpler, maybe also based in totally different sensors, which is checking that the whole behavior of the car still stays within a certain safety corridor. Yeah? And if there is a mismatch in the conclusions of both systems, yeah, then you can, for example, reduce the car's velocity, or you can, if this is just a highly autonomous function, you can call the human back, yeah, or you can even stop the vehicle if it is a driverless shuttle, yeah. So by that, you are reducing the complexity, because you have just one group of sensors which wants smaller intelligence, one group of sensors with a bigger intelligence, and it's not all feeding into one super big, super intelligence brain, high performance, where you have all these complexity challenges. Yeah. So I see a big chance to keep the complexity on a reasonable level while still taking advantage of all three basic sensor principles.
And I understand from what you're saying that you prefer to work on the principles first and understand them very well, and before you integrate, right? Luisa, is that the path to go from your perspective? Luisa, Andreone?
Yes, thank you. I do agree with this. Before, I really have nothing to add, because this is the way forward. Before simplification, you need to come to the point with the best technology you have. And of course, this is not my interpretation, but this is the interpretation I can give out of the outcomes of the activities we've done so far with the L3 pilot project piloting of the level 3 different functions.
Anna, can we come back to the question of the people that are using vehicles, or that may be exposed to automated vehicles on the road, say as pedestrians or cyclists, or how, from what you're seeing, how the question of intelligence of the vehicle is discussed here in this panel. Do you believe that automated driving will be intelligent enough to understand the intentions of people on the road in the future?
Big challenge as well. In fact, that's there is this part of intentionality is really coupled with more soft science, like psychology and cognitive science behavior. So we really need to make sure that the information that is inside the vehicle is also somehow coupled with the experience that we see on the reaction of the people. And then there is another completely new set of challenges, how the autonomous vehicle communicates with the user, with the road users.
I could imagine that infrastructure is playing a role there as well. I think Andreone was saying that if we would have an intelligent road crossing that knows very well what's going on there, and exactly like you were saying, would know how people are behaving and what's going on, that of course can contribute a lot. But my question here is, and actually this is a question that I've seen from the chat as well. If you compare vehicle-based sensing with infrastructure-based sensing, would you have any preference which one to focus on and which one to better optimize? Do these have to develop in a coordinated way, or do you see rather challenges here or there? So how about infrastructure sensing in this whole game? And maybe we start with Samia on that. As you have to consider that always your safety validation eyes.
So
What's your understanding?
I think that both are complementary. We have concrete scenarios or concrete cases where we see that the perception from the infrastructure is needed, like for example intersections with some maskage due to trees or some surrounding actors. But at the end of the day, the most important thing is not only to have information from the infrastructure, but also to have the right integrity level and the right confidence level with each information, because it's not only optional information, it's very important if we want to extend the availability of the ego car and not to make it stop at the intersection waiting for a teleoperator or waiting for somebody to solve the problem. This is the main question regarding the reliability of infrastructure perception data.
Maybe Sven, from a more technical point of view, I believe your perspective was very much vehicle-based, and what would change if you consider having all these different options in the infrastructure?
Yeah, well, with all due respect, Gereon, because you asked me to talk about the vehicle-based technology, so I talked about sensors, but people know me as...
Thank you, David. Sven.
But people know me as really a proponent of infrastructure for automated vehicles, and I personally believe that without an improved infrastructure, like level 4 automation will not be possible. Even level 3 automation, by the way, requires infrastructure. And I also see the questions in the chat here, and people are asking, what kind of infrastructure? What kind of infrastructure? Of course, we can talk about connectivity and if that's 5G communication or not. And I think communication infrastructure is important. But I'm also always quick to say infrastructure, road infrastructure for me starts with lane markings and starts with traffic signs that are readable by the sensors that I described. And if the audience maybe remembers my first slide where I had the Pepsi Cola can and the umbrella and all of these things, and in the top right corner, I had a stop sign that was hard to read actually for a human, but a human can still recognize it as a stop sign. But a camera and even less radar or a LiDAR could not read that sign anymore. And this is, I think, where we need infrastructure to make what is on the vehicle more complete, more intelligent, if you will. So I do believe it takes both. If in doubt, put everything on the vehicle, because then at least you know what you have, and actually your smartness, your capabilities travel with you, because infrastructure is limited to the location where it's actually implemented. And that means you can only operate your vehicle in a limited environment. So it comes with pluses and minuses, but I think infrastructure is needed. Otherwise, it will not work.
Let's stay with infrastructure for a moment, and I have a question to Luisa here, as you made us aware of the point that we need to consider what knowledge is behind the function of the automated vehicle. And before we consider having some artificial intelligence operating there, we always need to know what is the data that can be used in order to compare a certain situation with what the system is knowing. Yeah. How far do you believe will this further develop in the future? Can we imagine that there is, say, with the involvement of dynamic maps, quantum computers, whatever, a central knowledgeable brain or something that is, say, navigating the vehicles through the game of the roads or the traffic? Would that be imaginable? Would that be something you could wish at some point? Or do you think in the end of the day, there is still a role also of the people that are on the vehicle and that wish to decide things themselves? So what's your opinion about that?
Wow, very nice question. Thank you.
We are at the end of the session, so therefore I'm asking big questions.
So the answer of the big question stays into the users, and that is the users will tell us what they will adopt, not only what they will accept, because there is a huge difference between adoption and acceptance. But before wishing in one direction or in the other, having big dreams, the point is let's stay on what we need to do it. Like in the last question you did on the infrastructure, because if the sensors on the infrastructure are only, for example, able to say that it's raining, light rain, heavy rain, this is mean nothing. What we will need is the level of granularity of the different data from the infrastructure and from data from the sensors that we have on the vehicles. Then, of course, connectivity is a mean of transportation, is not a sensor. So that will make the exchange possible. And
Luisa,
then we can draw the dreams.
Thank you very much. Let me take this already as your answer to my final question of where the future research needs are, right? Because that's important in this context of the CCAM partnership, particularly here in key vehicle technologies. Where do we see further research needs? And I would like to go through all the panelists with that final question. And as time is running very quickly, we have another 3 minutes or so, maybe just one sentence each of you. And let me continue with Sven. If you're seeing this discussion here in Europe, what's your recommendation we should focus on?
So I think the research, especially on a European level, on a broader level, should be how do you integrate these automated vehicles in the existing traffic, and how do you need to adapt maybe existing traffic patterns, or where do you need to limit maybe a deployment of level 4 technology? Just to assume, take a very smart vehicle and add it to the mix, this will not work. So we need to research the entire setting, I think.
Samia, what do we still need to do? What do we still need to work on?
So I would say, in addition, sensing capabilities, sensing KPIs derived from safety expectations. This is one thing. And the second is the supervision of the AD system regarding the ODD and also regarding its capabilities in real time.
Maybe a quick question to Julie. Could you bring up the results of the second poll that people can see those in parallel to the final question? Thank you so much. Andre, from your perspective, where are the research needs?
If I have to pick one, then I would say perception, perception, perception. Bring something on the table, and with that package, try to convince the regulators.
Very well. We have not yet had the opportunity of discussing regulation. I know that there were questions in the chat on that too. Yeah, final question to Anna. Research needs, what would you recommend?
I think, as I said before, it's really important to have a good understanding of what is going on inside. So what are the right sensing, either to understand from the safety point of view, but also for the transition modes. And also, I would add that we need to couple this information with the contextual information. So what is the right contextual information we need to couple with? And last but not least, again, this is not just hard science. There is some soft science and social science as well. All this needs to be really understood with the psychology and I would say cognitive behavior of the user.
Right. So your responses are reflecting very well what I'm also seeing here in the chat as responses to the second poll. So people are, of course, emphasizing the need for environment perception. They are referring to the need of bringing together this with the different sensor informations. Data fusion is a big point. The integration in the vehicle is a big point. And of course, making these linked to knowledge, like Luisa already said in the beginning, bringing that as close as possible into the sensing systems and the architectures. That's a big challenge and the future research needs in the future. And then all these links to infrastructure, what it means in terms of connectivity, of where to put in the cloud the intelligence and the data. These are big challenges. We will review all these inputs and take those into account for further discussions in the CCAM partnership, and particularly in the cluster 2, but also cluster 5, so the one on vehicle technologies and the other on key enabling technologies, which is looking a little bit more in connectivity and AI. So with this, yeah, we are closing this panel. I'm thanking you very much, Luisa, Andreone, Sven Biker, Samia Ahad, Andre Holm, and Anna Rossi. Thank you very much and enjoy the rest of the conference. Bye-bye.
Thank you. Bye.
Thank you.
Thank you
Bye.
very much.